Good morning. I think there's been a bit of talk this morning about different types of models. So Alan mentioned design models, construction models, asset information models, and I'm usually asked, well, what does DBM stand for? Design, build, manage. So those are the kind of areas that we're working in, and you can see our company tagline, making design constructible and assets manageable, tries to solve some of those issues that we see between the design to the construction model and even the design, the construction to the asset information model. And so I'm going to talk a little bit about the company, introduce them, and then look at a couple of case studies where we'll talk about how we fit in on the design side, where we prefer to work in design, and then how we can deliver an asset information model as well. So, first of all, a little bit about the company. So we actually evolved from, I guess, 3 large steel detailing companies many years ago. They came together and the company has evolved from there. And, we're starting now to become a multidisciplinary digital engineering company, delivering all sorts of projects, which I'll talk about in a minute. So we're trying to take risk out of projects, which of course cost comes into that, reduces that for you. So looking at early design deficiencies, minimizing hours that are spent on projects, etc. Software agnostic, so we obviously have our own tools, but we'll use whatever tools people want to use on their project, and keen to do that. In terms of the company size, so we're around 950 people worldwide, offices in 10 different countries. UK, we're based in Oxford, plan to grow that side of the business to sort of match where we are with our operations in the US and in Australia. 55 years of experience, and that's kind of one of the things that we see as a big strength is being able to bring that real detailed level of experience earlier into projects. And with us having offices around the world, it also allows us to work 24 hours a day if we needed to advance the program. So what do we do? Digital engineering services, as I mentioned, integrated design, which I'm going to talk a little bit about with one case study today. We get involved in all sorts of things, but we try and solve solutions for our customers. So, as I mentioned, global presence, US, small office in the UK at the moment, and then offices, our headquarters in Australia, Brisbane, Australia. In terms of the types of projects, so I mentioned we had 3 companies that merged in the early days, one of which was a specialised bridge design engineering office. So they've worked on some fantastic projects over the years, and you can see some of those examples. Entertainment and stadia, probably one of our specialisms, especially in the US and Australia. We see a lot of these type of projects coming in. Complex projects that need a lot of work. In the UK, we've worked on a couple of new stands at Lord's Cricket Ground. Commercial jobs, some nice examples from Apple and Google, but I like the skyscrapers. They're the ones that I like to see. And our involvement on these, it might be from steel detailing, an RC detailing perspective, it might be from an asset information model, delivering that. And again, we have another project that we'll talk about later on. Industrial and mining, you can imagine with our head office in Australia, certainly Western Australia, we see a lot of these type of projects. And actually, some of these models are probably more advanced in terms of delivering an asset information model than a lot of the commercial ones that we see at the moment. They've been doing this for a while now. And of course, major projects. So not just buildings, infrastructure, Cross River Rail is one example of that, Brisbane Metro, and the other project I'm going to talk about today is Queen's Wharf in Brisbane, which was an award-winning project from Building Smart for use of Open BIM on quite a nice development. And of course, the nice visualizations and animations. Now, they can be useful throughout the project, the life cycle of the project, whether that's winning a bid, whether it's a very technical animation that may explain decommissioning. It may explain a complex lift or something like that. But certainly it makes it easier to understand a process that needs to happen. Okay, making design constructible. Early engagement is key on this. So we often work in a typical contract scenario where it's design, bid, build, and the problems you have to solve further down the line when that happens. Where we would like to work is part of an integrated design team, integrated delivery. Reason for that, it solves a lot of those problems up front. So if you're working as a part of the design team, you can look at things like modularization, off-site. You can look at logistics problems that you may have further down the line. You can look at fabrication issues that may come up with if a design doesn't take that into account. You can look at standardization. And so we're looking to get involved much earlier in projects and try and compress the schedule so that you're working as part of the design team. By doing that, you have to get the balance right in terms of the design development and how much detail is added at the right time. And delivery of that data at the right time is a key issue there. So one project where we worked with AECOM as part of the design team, Hong Kong Airport, third runway concourse, biggest project ever, or biggest spend ever in Hong Kong, massive project. You can see some of the figures there, lots of steelwork. But probably one of the key things there that I'm going to talk about is the process that we have in place to develop the connections much earlier in the design process than you would typically have. So working part of that AECOM team. AECOM, we're working in Rhino. We were able to bring their geometry and data through into Tekla via Grasshopper. The issue with that, it's fine while the geometry is developing, that can be updated quite easily, but when you start adding the connections, the details to the steelwork, then you get a few more problems in terms of, well, how does that update the model? How are those changes identified? And that's kind of one of the key processes that we had to put in place so that the design verification could happen in a timely manner and provide all the transparency and information that everybody needed. The process that we had in place for this one controlled something like 60,000 joints between steel on the model. And we were able, by developing a few parametric connections, to control more than 80% of the roof connections. So every time the geometry changed, then those connections would adapt automatically. That saves a huge amount of time. Excuse me. But of course, there has to be an easy approval process. Now, the way we did that was by exporting that data back into Excel, providing that back to AECOM, and they were able to interrogate the Excel connections then just to give an approval straight away. So it was an automated process, saving huge amounts of time and reducing risk that errors could creep in on the various different connections. Some of the benefits from working in that type of process, not only for, I guess, AECOM with the approvals, but also the client, greater understanding of the design by all on the project. So it gave, when you start looking forward to the fabrication, it gave much more early access into issues that may come up for the fabricator. The bill of materials is much more accurate. There's been talk about cost already, and if you've got an accurate bill of materials when you go to tender, then you're guaranteed to get prices that are much closer. They're going to be around the budget price. And a lot of the questions that perhaps come up when you submit a tender, they're already answered. So solve the problems up front. The aim was to be as paperless as possible, and there's been talk about paperless contracts for years, and they rarely happen. But being able to transfer geometry and maintain those models in a shared model environment, so everybody had access, doesn't get you all the way there. There's always going to be a need for those 2D drawings, it seems, but it does take out a lot of that 2D process. Typically, when you go to tender, the first thing you get is a bunch of RFIs that come back. And again, by adding that extra detail much earlier in the process, those can be taken out. That mitigates the risk. It stops any potential delays and claims later on. So what we found when we went to tender with that, they all came back within 5% of budget. That rarely happens on a traditional design, bid, build workflow. So to go to an integrated delivery is, to me, it's just a better way of working. So when I'm talking about making design constructible, it's about that early engagement. It's about bringing that downstream expertise earlier into the process. We often talk about early engagement, but it rarely happens. My experience is that people see that as the way that we should go, but I guess it's a slow burner. It's that cultural change. It's contractual change. Another example of this was soccer or football stadium in the US, Geodis Park, where we worked as part of the engineering team with Walter P. Moore. They're a forward-thinking engineer in the States, and we've worked with them on a few projects where, again, we're integrated as part of that design team. Now, similar processes in place, but the result, again, is what I wanted to focus on here, where the bids came in 10 to 20% under the budget, resulting in $3 million worth of savings on the steel package at that stage. So the savings to be had is just changing the process and perhaps changing the fees. So there's some of those are paid a little bit earlier, but that early investment does bring the results later on. So I want to move on to making assets manageable. I said before, there's already been talk about a design model, a construction model being very different to an asset information model, and that's our experience as well. You need to start with the end goal in mind, and the project I'm going to talk about is Queen's Wharf in Brisbane. So this was a project where we were brought in as the BIM lead, setting the strategy for the project with an aim to take the various models through to a serviced asset information model that could be used by the company that's going to maintain it for the next 99 years and provide a higher level of detail much earlier on. So we had to establish those project information requirements. We had to train the team on the project on those processes and workflows that we put in place. So that's quite a big task in itself. Managing the digital environment was quite a big task. You can imagine there's a lot of models coming together there, different types of models, different asset information. That all has to be controlled. Change management becomes a key aspect of that. And then we had to deliver quality asset data into Maximo at the end of that. So that meant managing more than 600 models, around 50 different model authors, 300 BIM flow, workflow activities that had to happen regularly to control the change on the project. And in terms of the data that's there, there's a lot of, as I think somebody said earlier, there's a lot of data that is generated on a project. Very much of it, a lot of it is rarely cleansed, it's rarely audited, but there was a process in place to control that and automate that so that the client would end up with the asset information that he needed at the end. And you'll see later on that there was a huge amount of data requested so that they can manage in the operations phase. So in terms of the type of data that we were having to manage for this project, existing conditions modelling, so almost modelling what's already there, what's in the local neighbourhood, what may affect the project. Looking at flood levels, it's right next to a river, so we had to consider that. But even with looking at the river, then there's a new bridge put in place. We had to look at the boats going up over the river and where they might travel. It's apparently quite an even riverbed, so there's only certain paths that they can take along the river. So there was analysis of all this sort of data. Modelling and coordination of all the subsurfaces as well, subsurface utilities. Geotechnical investigation, so everything that goes on with a big project, we were having to manage that. Cadastral models, looking at potential rental incomes in the future. Heritage setbacks, there's a lot of old buildings in Brisbane, so just checking that we're not interfering with them, we're not causing issues with the historical buildings. That was a key part of that. You're marrying historical buildings with a new development. It all has to fit in together. Excavations, looking at what needs to be moved and all that sort of information. So there's all this information coming in and has to be managed, it has to be cleansed, it has to be audited, it has to be checked. But once you've got that data and you've managed to probably reduce the amount you've got, you can then start looking at the data analytics and what that means. So I think a couple of people have spoken about the dashboarding. It's a key aspect of visualizing data. It makes it easy to read for the building owner, for the companies that go to manage it. But for a project like that, then you can see some of the figures of what needs managing. It's a huge amount of data for maintenance. Those models had to be able to be taken into Maximo, which is the asset management system the operator will use. And we were able to take that data through the geometry, as well as integrating our own model viewer that would allow you to link that information and visualize it at the same time inside Maximo. But as I said before, you've got to start with the end in mind when it comes to looking at asset information models. If you don't get those early processes right, those early requirements right, you don't get the outcomes at the end that the owner wants. And as we've said before, the project information models, the design models, the construction models are very rarely primed to go through to become an asset information model. There's a lot of work that has to be done for that to happen. And so that cleansing process, that removal of redundant data is a key part of that. But some of the benefits from that, greater awareness and access to asset information much sooner. That's a key thing for the O&M team. Managed handover. If you can centralize the data, reduce the work, then incorporate into operational environments is a key aspect of that outcome. Speed of information and transparency of information. Transparency is a key thing. If everybody is aware of where the data is it correct, then they can make informed decisions. If you don't have data that's been checked, been validated, you're guessing really, you're not taking an informed decision. Data ownership, ensure that you've got foundational data sets, they're owned, they're stored, they're built upon and taken into the asset information model. You can reduce safety and risk issues on a project. Risk is a word I hear over and over again. The more things you can do to take risk out of the project in any way, out of the process in any way, will benefit the outcomes as well. That's me done.